Welcome back to the Data Professor YouTube channel. My name is Chanen Nanta Senamad, and I'm an associate professor of bioinformatics. And on this channel, we provide tutorials and concepts about data science. So if you're into this kind of content, please consider subscribing. So in this video, we're going to talk about how you can modify or adapt the code that we have been talking about in the previous 2 episodes into your own data set. So let's have a look at some of the examples that are provided already in the dataset library in R. So why don't you fire up your RStudio or RStudio.cloud and open up the iris-data-understanding. For this file, iris-data-understanding, let's create a copy. Let's copy everything. Create a new file. Okay, paste the content. And let's save it as dhfr-data-understanding.R. So dhfr is a drug discovery data set. So let's have a look at that. Okay, so let's close the iris data set. Okay, so what you want to do for this is you want to load in the datasets library of R. And instead of saying data, you want to use iris. Let's have a look at dhfr. But before doing that, let me show you. If you type in data and then open parenthesis, you will notice that there are a lot of options for you to choose from. So you will notice that there's a lot of data set that you can play around with. So let's have a look. What do they have here? So they have the German credit data, Sacramento data, dhfr, scat. So there's a lot of data sets that you can play around with. Barley, environmental, ethanol, melanoma. Okay, so if you're starting out, I would recommend you to play around with the data so that you can get a glimpse of the various types of data science tasks that you could do. And because the data set are quite diverse, they are very heterogeneous in that some might be numerical, some might be qualitative. So you have a lot to play with. Let's say that you want to create a data mining model that will predict whether a compound or a drug will be a good drug or a bad drug. So let's load in the dhfr data set. So what you want to do is type in data parenthesis dhfr, right? And then you hit Control Enter. So we're just gonna skip this, okay? So we're just gonna comment it out. So the second method could be like this. So you could type in dhfr2 datasets and then colon dhfr. And if your dataset is available as a CSV and if you want to download it from your GitHub, you can use the following lines and then you could modify the name accordingly. So because we're not going to use it, so we're just going to comment it out by using the hashtag. Okay, so let's clear the environment from the previous session. Okay, so load in the dataset again. Okay, now you see that in the environment, the dhfr data frame now appears, and you will see that there are a total of 325 observations and there are 229 variables. So let's have a look inside. So Control Enter on the line saying view dhfr. Let me save that first. And then you will see the data frame here. So this data set, dhfr, is a data set comprising of 325 compounds. Each compound would represent a molecule, a drug molecule, and each drug molecule will be described by 228 molecular descriptor, which tells about the physical property, the chemical properties of the drug molecule. And the Y is the biological activity of the drug molecule, whether it is active or inactive. By active, it means that the drug molecule is potent against the dhfr protein, while if it is inactive, it means that the drug molecule is not efficient in binding or in exerting the desirable binding effect towards the dhfr protein. And so what is the dhfr protein? It is the dihydrofolate reductase enzyme. And so this enzyme protein is very important for having the anti-malarial activity. Okay, So we see that y is the property that we are going to predict, whereas there are over 228 descriptors that will be describing about the drug molecule. Okay, so let's do some summary statistics. So we replace the iris with dhfr. Okay, let's have a look at the head part. Okay, so we're gonna see the first 5 rows, first 5 data objects, and we see all of the column variables here. So there are over 229, meaning that it has 228 molecular descriptor, which are the independent variables, while one of the variable is the biological activity of the drug molecule. It is either inactive or active. Okay, how do I know that? So if you type in dhfr $, and then y, okay, so the $sign will allow you to select the desirable variable. And so you see that there are both actives and inactives. Okay, so there are 325 objects. And the tail will work in a similar fashion, but then you see the last 5 data objects of the data frame. Summary dhfr will allow you to see the summary table. So you see the minimum and the first quartile, the median, the mean values of the data set, or you can also have a look at specific columns. So when you type in summary dhfr $y, you see that there are 203 active molecules and there are 122 inactive molecules. So you'll notice that there is an imbalance of the data set. So in a future video, I will talk about how you can handle the imbalanced data set, because this will influence the prediction performance and also the reliability or the confidence that we have in the prediction results. Because when there is one class that is greater than the other class, okay, so let's check if there are any missing values. And there are none, of course, because these data sets have already been curated and they are example data sets that are commonly used when you are starting out data science. Okay, so let's load in the library skimmer, and then you just want to replace the iris with dhfr. Okay, and then you get to see the summary stats in more detail. So for each variable, you will have the various quartiles and the histogram distribution. So you see at a glance, the mean, standard deviation, is there any missing values, and the distribution, so that will come in handy. Okay, so what if you want to see the data by according to the group of active and inactive drug molecule? Then for species, we're going to just say it's the Y, or the biological activity. And so we're going to change iris to dhfr, and group by is going to be Y, because Y is the biological activity that we want to predict. And so let's control enter that. So we will see a summary statistics of the 228 variables for the actives and for the inactives separately. So if you have a look or examine each of these variables, they come in pairs, as you would notice that the name appears in duplicate, because one of them is for active and one of them is for inactive. So then you're going to see the mean and the standard deviation. So you're going to see that for the active molecule, the value of this mole 2D SAGREB is positive 0.195, while the inactive molecule will be negative at minus 0.181. Okay, so you can even do some t-tests to evaluate the significant differences among these two groups. Okay, so let's have a quick visualization of the data set. I don't think the plot will work because there are over 228 variables, but let's give it a try anyway, right? It's too big because there are 228 variables, so that is too big to fit into this plot, or probably it's too computationally demanding. Okay, so plot doesn't work here. So let's just comment it out. So you'll probably have to do it manually. You're probably going to have to visualize the data set manually. So what about we select some descriptors here? MOE, 2D, ACC, SAGRIP, let's have that. And then dhfr, $. Okay, and another nearby descriptor. Control Enter. Okay, here's the scatter plot of these two molecular descriptors. So there seem to be quite high correlation between them. Okay, and so you can modify this and add the colors to it. Right, so making it red color. So let's just make a copy of this. dhfr, $y. Let's have a look what happens here. Okay, so this will allow us to see the specific values of the scatter plot of the active versus the inactive compounds. So it's going to be color by Y, right? And if you want to label it, then so the x-axis is the SAGRIP and the y-axis is the Repurpose. Okay, so the label changes now. So let's have a look at the histogram. So then we will go for dhfr $MOE 2D_SAGRIP. Control Enter. Okay, just copy paste this. Okay. Let's see if this works. dhfr, and then species will become Y. So we're going to have a look at the first 4 variables. Okay, so that didn't work. Let's see what's wrong here. Okay, I think I know. So we should change 1 to be, let's say, 2 to 5. Because the first one is the Y variable. Okay, now it works. So now we're going to see the feature importance plot for the active versus the inactive drug molecule for the first 4 molecular descriptors as shown here, because the first position is occupied by the Y variable, which is the biological activity. And so we're going to show the second column to the 5th column, which represents the first 4 variables. And so that's the feature importance plot here. So we could try more if you like. Let's go for another 4. So we'll have 8. Okay, I'm not sure how many this will be able to handle. Let's go with another 4 and another 4, shall we? Okay, so it's missing 2 more. So let's make it, 2 more. 21. Okay, there you go. So we have a 5 by 4, very cool plot. You can click on the zoom button and then you're going to see a bigger preview. So here we can quickly see that some variables, there are no significant differences between the active and the inactive drug molecule, like for this F charge. So both are pretty much having not much data. So the data variance of these active and inactive drug molecule are not different because there's no variation in the data distribution because they are essentially almost all zero, having all zero values, whereas for the inactive, there might be some having some information, whereas the rest have no information at all. It lacks the data, probably have a value of 0. Okay, so this variable, we probably will have to cut it out. Okay, and so for the other one, we can see the differences that can be observed between the actives and the inactive molecule. Okay, so this concludes this first script on the data understanding, and so let's continue to the next one. Okay, so let's now proceed to the iris classification file. So we're going to copy all of the code, and then we're going to move it into a new file. So let's clear the memory again. So let's load in the datasets library, load in the caret package, load in the dhfr dataset. So for this, you might need to use the RStudio.cloud because I already checked previously that the RStudio did not have the dhfr data. So it might just be a version thing. Okay, so let's load it in. Okay. So I'll tell you what, I'll create a CSV file of this dhfr, and I'm going to upload it to the GitHub of the dataprofessor. And so I will share the links down below. Please check in the description. Okay, check for any missing data. So now we're going to set the seed. Okay, and for this data splitting, we're going to change iris to be dhfr. We're going to change species to be Y, and we're going to initiate that. So let's type in the dhfr here and dhfr, and then let's run it. Control Enter, Control Enter. Okay, so 261 objects and 64 objects would add up to 325. Okay, so we're just going to skip this. And let's go ahead and save this as dhfr-classification.R. And so model equals to train, species would have to be Y, and then everything would be the same. For the CV, species would be Y, everything else would be the same. So let's run this, Control Enter, and then let's build the cross-validation. So for this, I have to change species to Y. Okay, now let's have a look at the prediction results. So the model training confusion matrix is shown here. So we see that the accuracy was 0.9923, and for the confusion matrix, we could see that most of the molecules, 162, were accurately predicted to be actives, whereas one of them is mispredicted to be inactive. And out of the 98 inactives, one is mispredicted, while 97 was correctly predicted to be inactive. And so the sensitivity is 0.9939, specificity is 0.9898. Okay, and so that's for the training set. And for the testing set, the accuracy is 0.9219, and the confusion matrix revealed that out of the 41 active molecules, 3 were mispredicted to be inactive, whereas 38 were correctly predicted. For the 23 inactive molecule, 2 were mispredicted to be active, and 21 were correctly predicted to be inactive. And the sensitivity is 0.95, specificity is 0.875. So let's go to the cross-validation. The accuracy of the cross-validation is 0.9923, and out of 163 active drug molecule, one of them is mispredicted, whereas 162 is correctly predicted to be active. And out of the 98 inactive molecule. One of them is mispredicted to be active, and 97 is correctly predicted to be inactive. And the sensitivity is 0.9939, while the specificity is 0.9898. Okay, so now let's have a look at the feature importance. So importance, variable importance function. Let's run this, Control Enter, and then let's have a look at the plot importance. And so you're going to see that there are so many descriptors, over 228, and so it's very difficult to see. Even if we click on the zoom button, there are over 228 variables and very hard to see indeed. So what you want to do is you want to probably visualize, let's say top 25. So we're going to add the top equals to 25 to the plot function. And here you go. You're going to see the top 25 descriptors having been ranked according to the importance. Okay, so that's all for today. Thank you for watching. Please like, subscribe, and share, and I'll see you in the next one. But in the meantime, please check out these videos.